architecture, what's the status of it, what's happened in the last 12 months. I'm going to do a quick overview of the progress, and then I'm going to open it up to the floor for a discussion on how projects, distributions, etc. are dealing with ARMv7, issues that are encountered, things that you feel other distros could benefit from, things that maybe ARM could benefit from. I'm not saying we're perfect. We're close, but not quite perfect. So, you know, it's all about getting dialogue going and working together. So, the evolution has been fairly rapid over the last 12 months. There's been quite a lot of work. Some of it's not overtly visible, but some of it's been more of code cleanup, etc. So first one is kernel. What's happened with the kernel? Biggest item really is unified kernel. This allows a single Z image to boot 5 different platforms. It's still work in progress. We're trying to get more partners on board. One of our biggest issues is the diversity of kernels required to boot the large number of platforms that are available. It's not perfect, but we're getting there. And take 3. Aha. Another item that's being introduced, it's not quite upstream yet, but code's public under review, is support for M-class SoC, so the microcontrollers, Arduino style devices. So that's slowly coming. Another improvement, thanks to the likes of the A7 and A15 class, the A class, is virtualization. With A7 and A15, we introduced virtualization extensions to bring it on par with other architectures. And with that, both major hypervisors can now run. There's a debate, shall we say, over which one's more advanced, whether it be KVM or Zen. From our perspective, we just want them to work. So we're not going to get involved in any discussions of that nature. But again, things not quite 100% there. There's some issues around some of the tools, trying to get them updated so it supports hypervisor correctly. OpenSUSE are using KVM now on an A15 board as part of their build service, so we know it does work in the real world. The A7 should work the same as the A15. There's not a huge number of A7 based boards out at the minute, so it's a little bit harder for real world stress testing. Then power. ARM's always been known about low power, and we try and continue that. Big one is big little. So cluster of A15 cores with a cluster of A7 cores working in tandem. There's two schedulers for big little. There's what's known as IKS, in-kernel switcher, is being used at the moment. With that, it's more of a CPU governor methodology. So it will, if you have a low powered workload, it will schedule it on the lower CPU, so the A7. If you get more intensive usage, game or whatever, LibreOffice maybe, or something similar, it'll bring in the A15 when power's needed and then drop that out onto the A7 again. The other switcher available is the MP switcher, multiprocessor switcher. Code is public, not quite upstream. Still needs a bit of a cleanup. That's more of a CPU scheduler, so that will schedule the workload as required. And one of the key differences between IKS and MP, with IKS you can only use one of the CPU clusters at any one time, so either the A7 or the A15. With the MP scheduler you can actually use both. First devices that are shipping later this year, for instance the Exynos 5 Octa, I'm not 100% sure on which schedule. I've got a funny feeling that's going to be the IKS scheduler to start off with. But with the MP scheduler, you'll be able to utilize all 8 cores as required, and the scheduler will just assign the workload as required to the CPU. Compilers, always needed. Both LLVM and GCC work. LLVM supports A class only at the moment. Work is ongoing. GCC supports all 3 classes, A, R, and M. So that's the most widely used compiler at the moment. The enhancements to GCC have been fairly varied. There was quite a big focus on A15 and A7, improving the pipeline there. A15, with those improvements, sees performance uplift of upwards of 5%, so fairly significant. There's also Neon support within GCC. Neon is ARM's advanced SIMD processor extension. It helps with high performance audio and video processing. That's all great, but how can you leverage it from a Linux perspective? Well, Project NE10 was released by ARM, an open source library that makes full use of Neon. It's BSD3 and Apache 2 licensed, and it's available at projectne10.org. It's available now, and its code's hosted on GitHub, so usual pull requests are more than welcome. Next enhancement to ARM v7 is Grub. We all use it, or most people use it nowadays, and work's begun. Not quite upstream yet, but it's under code review. And Grub now supports both U-boot and UEFI. So it, just takes a system firmware, regardless of which one it is, and will boot from there. So moving from one architecture to another, you get the tools that you're used to. Again, it's still work in progress, but the foundations are there, and it is working now. Linaro has been around for about 2 years, just over 2.5 years or so. It's a great melting pot of minds for those that are interested in the ARM space. The couple of key RFC channels and mailing lists take note of. Linaro is the main development RFC channel, where almost all the developers loiter around, discuss things. And Linaro Enterprise is RFC channel that's focused around ARM, Linux in the enterprise space, so the traditional server market where improvements are ongoing to get things up and running. They also host a cross-distro mailing list, which is at present very low traffic. I'd love to see the traffic pick up there for people to actually discuss anything to do with ARM on their distro, whether you're Debian, OpenSUSE, Fedora, Arch, whoever, and to discuss issues that you're encountering, any bugs that could be prevalent to other distros. They may have found a fix that you're not aware of, and it could be a quicker and easier way than trawling through Bugzilla or any other bug tracker trying to dig it out. They also host 3 conferences, Linaro Connect. They normally have one in Europe, one in Asia, and one in the States. And almost all the developers from members of Linaro meet up there, discuss, plan, hack, and generally try and improve the way things are going now. It is a charged for event, but it is possible to potentially get some sponsorship if you're running short on cash to attend. There's no guarantees, but they'll try to help you along how they can. So that's my slideware done, and it's now more of a discussion. Just curious as to who we've got from which distributions. I can see some people that I recognise. So anybody from, sorry, question? Okay, so those that didn't hear the question, gentleman in the corner there is upstream maintainer for Grub, and he's asking if the code could be committed upstream. My understanding is the code has gone through review internally to make sure everyone is happy that it works and how it works. My understanding is that it is being submitted upstream. I know the gentleman that worked on that is actually here, so I shall grab him by the ear and make sure that he does that as soon as possible. Okay. Yeah, no, that. I appreciate that, and it like I say, ARM has, due to the nature of our business, a fairly strict regimen that needs to be followed for code submissions, not just from a legal perspective, but also to make sure that our code is sane and stable to be submitted upstream. So I know it's gone through at least the first two stages, so the third stage is to get the code into your hands now for your approval. So I'll make sure that gets done. Yeah, no problem. Like I say, I'll make sure that the discussions happen Monday at the very latest, if not sooner. Maybe I can introduce you in person and you can go through exact details this weekend. But yeah, I'll make sure that happens, because it's in my interest, or shall I say, it's in our interest as well as yours, to make sure that that code is upstream and merged, so everyone can benefit. One of the questions I had was, is there anybody here from Arch Linux at all? Dealing with their ARM port? No. Anybody from Fedora, or are you all at John Masters' talk? No. Debian? Good old Debian. And OpenSUSE? Yeah. Gentoo? Let me see. Ubuntu? Or are you all going under the Debian banner? Great. I mean, basically, has there been any major issues within your distros when supporting ARM on v7 that you've encountered? So yeah, I mean, for those that didn't hear the original question, the question is there any plans, or what are the plans to unify installs from a OS perspective. So rather than just U-boot, how can you get the installer to work as it does now on x86, where you can choose components. Basically, you want to have parity on ARM as you do with x86, which ultimately is our goal. Part of the issue is needing to get the silicon vendors to agree as well on that process. ARM can make recommendations and requests, but that's not to say that a silicon vendor does their own thing because they know better. I can't make any promises, but I'll make sure that we try and get that track going. It might be a good tack for Linaro to take, to try and, as they have many of the silicon vendors that are working on not just consumer devices but also enterprise devices, it may be an easier forum for their, for them to actually get that sort of thing to work. I'm not entirely sure if they're already working on it with the grub work that's going on, but I'll certainly try and get something out that strawmans the ideal track to take. But it is a very valid point, because at the moment, if you want to install on an ARM device, it's effectively just DD your image. You don't get that granularity that you used to on an x86 machine, which isn't ideal, to say the least, but very valid.
What can you say about accelerated graphics drivers and the likelihood that some of those are going to be made more open?
Question was, what can I say about accelerated graphics drivers and if they'll be open? No comment. But graphics drivers on Linux are always a thorny question. They're much better now on x86 than they used to be. They're not perfect, but they are ahead at the moment of ARM in so much as you can get some open source accelerated graphics drivers. There are discussions on how best to go about it. It's not very easy because there's a whole heap of IP involved. There's the Lima project that's working on trying to create an open source graphics driver for the Mali 400 series. But officially, I genuinely can't make any comment, as it's something that I'm not really able to for legal reasons, in all honesty. It's something that I'm working to try and rectify, but that's long-term goal, 5-10 year type goal.
Not just this community that would like that, but the silicon vendors struggle a great deal. They get the shit done. So a different company like Benson might feature on a bonus.
Yeah, so getting silicon vendors to push for that may be the right tack to go around. Again, it's not something that I can say authoritatively on, but it's a well-acknowledged issue and shortcoming, and it's something that's going to take quite a bit of time to rectify. Any other questions from anybody? No. Nobody's got any issues with ARM. We are wonderful, working perfectly. Yeah. So, question is, how do I see trust zone integration in the mainline kernel? For those that aren't aware, trust zone is a low-level secure layer that run on Cortex A series SoCs. It's used predominantly by financial institutions, banks, etc., for authorizations. It's also now being used for media applications, so DRM authentication for playing back video files, etc. I'm not entirely sure how Trust Zone is being looked at from general Linux perspective and how it can be integrated into mainline. There are discussions on how Trust Zone can be utilized within the general Linux space on server side for authentication perspectives, so SSH key type authentication. It's still out there. Do you have any opinions on how? Yeah, I've already repeated the question, so we've only got the one.
That's fine. Okay,
Yeah.
sorry.
Sorry about that.
Should be on.
Yep. Yeah. Sorry. You kind of touched on one of the biggest issues there. The SoC disparity in working along the same way for the same goal. Again, that's something that would need to be brought up in a forum where SoCs can actually agree. It may start to improve a bit now that Trustonic's been created, which is going to be dealing a lot with secure zone workloads, etc. So I can take that item back and see what the idea is and try and make a mention of it, and I can discuss with the secure zone guys on how best to integrate that in mainline. But at the minute, I can't really say.
Yeah, so what I think would be useful would be some sort of standard or guidelines from ARM which says these functions we expect to be offered by the secure layer, and this is the API you have to use to actually use them. And maybe you could, I guess there might be also from the security side services which are very common and have have almost the same semantics across various implementations, but are of course again not exactly standardized.
Yeah, I think part of the issue may be the fact that because it's interfacing with Secure Zone, there is potentially the fear that, well, if we have this public API, then that means that we're opening attack vectors into Secure Zone.
That shouldn't be the case. I mean, if your secure implementation is correct, there shouldn't be a problem in publishing the API, right?
Shouldn't, but I'm just playing devil's advocate here in so much as the guys may go, no, we don't like other people being able to snoop around or whatever, even interfacing. It's called Secure Zone for a reason, such like all what I can promise is that I will go back to both the kernel teams and the Secure Zone teams and see what their views are and see if we can get something moving forward. Sorry.
Okay, thank you.
Any other questions? How are we doing for time? Still got a bit of time. Yeah. Sorry. Sorry, I'll repeat the question.
That will integrate ARM cores.
Sorry, can you just repeat the question now that you've got the microphone? PGA?
FPGAs.
Oh, FPGA vendors. So what FPGA products may be coming out, I have no comment on that, in so much as ARM don't actually manufacture anything.
Yeah, I know.
So you would need to go, we license the architecture design, and then vendors like Samsung, Qualcomm, Nvidia, etc. They then take that design and build up on it, and build products from that. So you would really need to speak to the hardware vendors to try and find out what their product roadmaps are. I mean, personally, I find out what products are shipping almost the same time as most of you guys will find out from, whether it be The Verge, Engadget, whatever, usual online sources. So it's not something that I can really say. It is really down to hardware vendors on what they plan on doing. So there are V7 is going to be around for a while, and there are new products coming out based on the architecture. So I mean, the next big product is going to be Big Little. So Samsung's Exynos 5 Octa is the first announced product. There are going to be more, I'm assured. So Big Little is different to NVIDIA's implementation, where they have quad core plus one. So with Tegra 3, you've got a much lower powered helper core that's used at boot up. Once the system's up and running, it then hands off to the quad core for running applications, etc. So that's the next big one.
It works slightly different, but basically the boot doesn't actually happen on the low power core. The boot happens on a small ARM7 we also use for co-processing stuff, for video decoding, and then that one boots the normal cluster, and then depending on the load we switch back to the low power core.
Yeah, I mean, it's Big Little-esque, but not quite.
The major difference between what Tegra does and what Big Little does is that it's not cache coherent, so we can't run all cores at the same time like you can in Big Little. That's actually the major difference. And it's also not symmetric.
Yeah.
And the not symmetric thing is something which you can of course also do in Big Little. Big Little doesn't have to be symmetric. It's just that the first implementation apparently will be symmetric.
Yeah.
But there is no requirement for it to. Yeah, there's no requirement for it to be symmetric.
No. Quite correct.